Hello all, welcome to part 2 of the wireless LAN security mega primer. So now in this part 2 we'll look at a little bit more interesting stuff about how to go about understanding the art of wireless packet sniffing, and in the process we will also learn about channels and different bands. So let's move forward. So understanding wireless sniffing. Well, I think most of you may understand a little bit about wired sniffing at least, and the concept is very similar. What we did on the wireless side is we put the interface on what is normally called the promiscuous mode, right? Once our Ethernet card is put on promiscuous mode, it accepts all packets it sees on the wire, regardless of whether it is destined for the current host or not. Similarly, in wireless, we have the concept of monitor mode. When you put a card into monitor mode, what it's going to do is it's going to go ahead and accept all packets it is seeing on the current channel, right? Now there are a couple of inbuilt tools in BT to help us quickly put a card into monitoring mode and actually go ahead and sniff the packets. Our tool is going to be Airmon NG, which is part of the Aircrack suite of tools, which you will look at in more detail in future videos. Okay, quick lab time. Hope you also have the similar setup with you right now. So let me whip out my backtrack instance, which we have already created and we have configured as in the previous video. Let me go ahead and switch to full screen. Okay, let's go to full screen, switch, perfect. Now what we are going to do is, first of all, we'll again plug in our wireless card, just like in the previous video. Plugged it in, give it a second, let me quickly do an ifconfig -a, and our card is here, right? So now the first thing to do is bring up this wireless card using the ifconfig wlan0 up command. Now interestingly, this takes a bit, and what is the only indication is a quick flicker in the LED here. After that, the card does not seem to be giving any signs of it actually being connected. I guess the flicker is based on the amount of activity which is happening. Anyway, so now the good news is we have the WLAN0 interface up and running. Now here is something interesting. We cannot start using this WLAN0 interface for sniffing immediately. And what we will have to do is actually create a monitor mode interface sitting on top of the actual device interface, which is WLAN0. So for that we use this utility called Airmon NG. Now when you run Airmon NG without any arguments, it will go ahead and show the available list of wireless interfaces and the driver which has been loaded, right? So to create a monitor mode interface on top of WLAN0, what we are going to do is issue the command Airmon NG start WLAN0. Now once we run this command, it actually gives you a message saying monitor mode enabled on Mon0. Now what has actually happened is, let's run Airmon NG without any arguments. A virtual interface Mon0 has now been created. Okay, interesting. And if we actually do an ifconfig, we will see that the Mon0 interface is also up and running, and it also has the same hardware MAC address as our original Wi-Fi card. Now for all purposes of sniffing, we will only use the Mon0 interface, right? So let's do the following. Now we have an interface which is capable of monitoring the air, right? You can also do an iwconfig and you should see the Mon0 interface. A key difference is in the mode, you'd actually see monitor has already been mentioned for Mon0. Now let's launch Wireshark. should not run as root, absolutely. We click on capture interfaces, and if you notice, Mon0 is already having a good amount of activity. So let's hit start, and now we are able to see a lot of traffic around, right? Let's just stop this capture for a second, and if you notice, we are able to get the IEEE 802.11 frames, which are basically your wireless frames. So this is how we, using our alpha wireless card, we created a monitor mode interface using Airmon NG called Mon0, and we are now sniffing on this interface, right? Okay, so let's quickly go back to our slides for a second. And let's move on. Now, you may have actually thought this is all there is to Wi-Fi sniffing. Surprise, surprise. Wireless sniffing is a lot more complicated, and here is the reason why. First of all, wireless LANs operate in 3 different frequency ranges, right? So any given access point can actually choose between any of these frequency ranges, of course, depending on its hardware capabilities. And these ranges include the 2.4, 3.6 and the 4.95 gigahertz ranges, right? And there are different wireless standards which we end up using. So you have 802.11bgn, which operates in the 2.4 range, Y, which operates in 3.6, and AHJN, which operate in the 4.95 range. Now, interestingly, these range are actually just a band in the spectrum, and they are further subdivided into individual channels. And at any given instant, your wireless card, which is the alpha card which we are going to be using, can only be on one channel. Very, very important concept. This card, because it only has a single radio, can only be on one channel at a given time in any given frequency band, depending on the hardware capability of the card. Also, most interestingly, every country has a list of allowed channels. The users who are allowed to use that channel, for example, everybody, the military, things like that, and the maximum power level which you can transmit on that channel, right? Now, a lot of cards and access points come pre-configured with all of these settings, but interestingly, you can very easily override them and change this configuration and disregard the policies. Now, here is a sample list of 11 BGN channels which are operating in the 2.4 gigahertz range. I've taken this and a couple of other information directly from Wikipedia. Acknowledgement to the source. Now, interestingly, we have channel 1, 2, 3, so on and so forth, and this is the actual frequency in megahertz of these channels. Then after that, we have North America, Japan, and typically most of the world, where whether an access point or a card is allowed to transmit in that channel is mentioned. As an example, on channel 12 in North America, you cannot use it. However, in Japan, you can, right? Subtle differences. But as we mentioned, the card itself, if it has the hardware capability, can be forcibly configured to actually jump and transmit to channels which may not be allowed by the country you're residing in. However, please be warned, that could be illegal. So what are the key differences between wired and wireless sniffing, right? First, of course, is we have a concept of band and channels in wireless, while in the wired side, there was nothing like this, right? Basically, you could just connect your Ethernet wire to a hub or to a switch, and whatever traffic your wire sees on that port is going to be shown directly to you, right? There is no other configuration required. Unfortunately, in wireless, you have to choose the band and the channel depending on the hardware capability of your card, right? Now, why do I say hardware capability? Well, for example, the alpha card which we are using, if you kind of check behind it, it says it can only operate in BNG, which means A, N, and some of the other operational spectrum bands cannot really even be accessed by this card, which means if there is an access point operating in N, this card will not be able to see any traffic from it. Right? Very, very important. So which means your card needs to have hardware capability to be in that frequency band before you can start sniffing. Okay. So quick iteration, wireless card can only be on one channel at a time. Why? Because there's only one radio. Cannot sniff on all channels and bands at the same time. Well, this is like a corollary, very simply because uh, there's just one radio, and at the most what the card can do is some sort of a time division multiplexing between all these different channels and hop across these channels. However, at a given instant of time, it can only be on one channel. Also, the card needs to be capable of operating in the given ranges, whether it is A, B, G, N, or whatever, right? Now, important to note, the alpha card which I am using is only capable of B and G. Okay, so if you have another card which is capable of other frequency bands, well, great, you could use that also. Okay, so now given this, how do we go ahead and first figure out on which channel are we on, and second, how do we make the card hop channels, right? So this is the next part of the lab. Let's bring up our backtrack machine, go to full screen, right, and let's minimize Wireshark for a second. Now if we actually do an IW config very quickly, you notice that basically the card can only operate on B and G, right? Now one of the things which you can actually do is put the card physically on any one of these channels. So as an example, you can actually say IW config WLAN 0, say channel 1, right? And this would actually put the card on channel 1. So if you notice, it actually says frequency is 2.412 gigahertz. And if you check, this would actually end up being channel 1. Right? Now, couple of other interesting things which you can do is, how do you now make the card cycle and hop different channels while you're looking at what is available in the air, right? To do this, we have this interesting utility called Aero Dump, which is also part of the Aircrack suite of tools. And by default, Aero Dump is going to hop on 2.4 gigahertz channels. This is something it mentions when you run Aero Dump without any arguments, right? You can even make it hop on different frequency bands or specific channels. Now in our case, because our card is capable of B and G, if I remember, we can actually tell Aero Dump to operate on both of these bands, and the interface we are looking at is Mon 0, right? So now take a look at this. The channel here is showing on which channel Aero Dump actually is, and as you can clearly notice, the channel is keeping on changing, right? So Aero Dump has a lot of algorithms it uses to actually hop across various channels, right? You can read through the documentation to actually figure out what are those algorithms which you can use, round robin, random, etc., etc. And as you can see, a lot of access points are currently starting to show in the output of Aero Dump. So very simply put, you can visualize Aero Dump as a simple utility with which you can discover the network around you, right? So in this case, we have all the access points listed on the top and the clients listed on the bottom. Clients could be your laptops, smartphones, or any other device capable of doing Wi-Fi. We'll come to details of what each of these columns, etc., are in later videos. So concluding this video, what we have learned right now is how to go ahead and sniff on wireless. We have understood that unlike the wired side, on wireless we have to choose a specific channel in a given band. And what we can at most do with just one card and one radio in it is hop channels across various bands as fast as we can to get an overall picture about how the wireless network around us looks like. However, if we want to get each and every packet, then we can only concentrate on one channel at a time. Right, so let me switch from the full screen view and go back to our presentation. So I would really encourage you to try all of these exercises by yourself. Wireless is a very practical subject, and because of that, unless you're going to go ahead and really sit down and try it out yourself, you'll just end up getting more and more confused as we progress further. Anyway, hope you enjoyed this session. Please leave your comments behind like always. I really look forward to read them. And this week is the week of wireless, where you're going to get all the wireless security videos. That's all for this video. Thank you. Enjoy. Bye-bye.